So this is a presentation I used to give at the Zilker Botanical Garden. I'm only doing parts of it today, but this is part of plant propagation. I'm going to specifically talk about the shape of plants, maybe stomata, maybe sporangia, and specialized structures of plants. So, what a time to be alive. I'm going to start streaming this on TikTok right now. Plant propagation. Propaganda? Boom, 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 boom. We love propaganda. There's our little homosexuals. Alright. I might move my face periodically. The Eterna Forest theme would be perfect for this. Yeah. It's a little ominous. But it's got the right vibe. You got it. Okay. Today, the beginning is going to be about plant morphology. So we need to understand the shapes of plants. And morphe means form, and ology is a study of. So it's a study of the plant forms. Let me see if I move my face. This wasn't designed for face. I'm serving face. Is that what they say? The study of the physical form and structures of plants. So plant morphology is a study of the external form and structure. So everything you see on the outside of the plant is its morphology, and everything on the inside is the anatomy. So plant anatomy is the internal form and structure. So if you're looking at the structure of the outside, it's morphology. If it's the inside, it's anatomy. Anatomy means to cut open. So that's internal. So plants are pretty easy. They got two things. They got roots and shoots. And that's it. Isn't that easy? Done. We're done with the presentation. Thank you very much. No, just kidding. Okay. The roots, it has roots and shoots. And we can further categorize them. Shoots are comprised of stems and leaves. Stems and leaves. Yoban, you are correct. Roots and shoots sounds like team names for college football sports. It does. Oh, roots and shoots. In Hawaii, people say shoots. And so I'd make a joke about that. But this is not, we don't speak pidgin, most of us. So roots and shoots. Shoots have leaves and stems, and roots are primary roots and secondary roots. Easy enough. So the shoot is the thing above the ground mostly, and it's just two things, stems and leaves. This is my beautiful illustration. A beautiful illustration I drew in 2019. You have shoots on top, which has stem and leaf, and you got roots on the bottom, which has taproot and lateral roots. The taproot's the main one, and then lateral is the ones coming off. Sometimes they're called secondary roots. Big Sleepy Lion, thanks for following. Now, I'm going to throw a bunch of jargon out, and then we'll simplify the jargon. So, I'm going to give you a very comprehensive look at this. I'm going to keep moving my face, because that's fun for me. So the stem is defined as indeterminate. So if this stem is indeterminate, that means that it will continue to grow unless it's prohibited by the environment. So indeterminate means it does not have a set genetic stopping point. So the stem will keep growing and growing and growing and growing. And the stem has certain things on it. The stem has a shoot apical meristem. So the shoot apical meristem is the primary growing point of the stem. This is the meristem is in humans we have a thing called stem tissue that can become any type of tissue. Well, if we called it stem tissue, that'd be confusing because this whole thing is the stem. So we call it a totipotent section of cells. The cells can become anything. They're totipotent. They're totipotent cells. Now, there's other meristems at the base of the leaves. The meristems at the base of the leaves are called axillary buds. And those axillary buds can also grow, but they're inhibited by the apical meristem. There's also things called nodes. So the node is where the leaf connects to the stem. And at the base of the leaf, that's where you find those little buds. And the space between nodes is called the internode. Yeah. It's the stem, the piece of the stem between the nodes is the internode. Yolban. Matthew Van Gogh over here with that illustration. It was superb. My illustration skills are getting better. You know. That is why I cut before the node, and it will grow from the bud. That's right! Seabass. You got it. The internicy. Crazy. So, summary. The stem will not stop growing, and it has buds and nodes. Easy. Now let's look at leaves. So leaves are defined as determinate, which means they have set genetic factors determining how much they will grow. They have a determinate point. A leaf will only get so big. It won't continue to grow. And a leaf is defined as arising at a node. So a leaf, all of the terms in yellow are like jargon. These are just terms that are specific, like botanical terminology. The leaf is connected at a node, and the node has an axillary bud at the base of the leaf. So this leaf is connected to the stem at what's called a node, and the base of the leaf is called the axil, and so the bud that's in the axil is called the axillary bud. Look at that leaf. Okay. So the leaf will stop growing, and it's connected to the stem at a node. So that's the definition of a leaf. The petiole. The petiole is the little piece of leaf tissue that looks like a stem that connects to the stem. So the leaf has the flat part called the blade, and it has the little stick part called the petiole. It's the stalk of the leaf that connects the blade to the stem. The leaf is the plant's rising sign. I don't think I understand astrology enough to know what that means. If the plant loses a leaf, will it grow a new one from the node? It could, or it could grow a whole new stem. So it depends. It's a great question. Typically what happens, so if it's a deciduous plant where it regrows the leaves all year round, then probably. If it is a tropical plant, then maybe not. So the apical meristem on top is the primary growing point, and it emits hormones that inhibit the other axillary buds from growing. But when this point is far enough away, sometimes the buds that are that are a significant distance down start to grow because they're not being inhibited by the apical meristem. So if the leaf is removed, there sometimes is a chance for this node to start growing, and it usually grows into like another branch. But generally, on most houseplants, no. So these are examples of petiole. This leaf has a really long petiole, and if it has no petiole, it's called sessile. So this is one leaf. So basically, I told you everything that a plant is, and everything is a variation on that theme. So plants follow the pattern of leaves are at nodes with buds on stems. So a leaf is connected to the stem at a node, and at the base of the leaf is a bud. Everything follows that pattern. So once you know the pattern here in purple, everything else in the plant is exactly the same. It's just a crazy variation, and some of them are extreme. And so today, the letter of the day is S, for specialized structures. And so we're going to look at some specialized structures that follow this theme. Relaxing wave, hello! We have a new oat redemption, which is plant presentation. And so we have redeemed a plant presentation, and we're doing that today. So we just saw that leaves are at nodes with buds on stems. So this is my illustration from 2021. Hydrate, thank you, Adam. Okay, we'll skip this part. If we do a morphology section, if we do a morphology presentation, we'll do that. But today we're doing specialized structures. So we're looking at the unusual things. Seabass, you have a purple heart plant that has grown long, but the leaves are only at the end, because I really don't know to take care of it when you got it. Okay, well, you could technically propagate that one. You could cut the end off and grow them. Regrow it from the tip. The purple heart, Tradescantia pallida. Yeah, that plant, it might make branches, but it might not make new leaves back there. Does the presentation touch on variegation? This one doesn't touch on variegation, but I do have other presentations. Variegation is when a plant produces colors different from the wild colors. And so, yeah, we won't talk about that right now. But we could for another plant presentation. Okay, that looks like you on vacation. We're going to go through the unusual structures of plants. This is the flower of the opuntia, which is prickly pear. It doesn't have petals, but it has things called tepals, and it can have like 34 of them. And this, remember we said that there's leaves at nodes? Well, this is a cactus, and the stem tissue, yeah, prickly pear, tasty. This cactus, the stem is green, and the leaves are actually the spines. And at the base of those spines is the buds. So each of these new sections of stem is growing at where the buds were. We eat our cactus too. You grow them for fruit. Tepal sounds like the Dutch word for nipples. Oh, really? Interesting. Yeah. So each of these little bumps in a cactus is called an areole, but that's just a node. The spines are leaves. The stem is called a phylloclade. When the stem becomes flat and green, then it's like, oh, this kind of looks like a leaf, but it's not a leaf. And the stem mimics what a leaf does in its function, called a phylloclade. The areole is the axil. Areola grande. And then the spines are leaves. Okay, specialized structures. Bulbs. The sulcata tortoise. Sea bass, wait. Your tortoise likes to eat prickly pear. There's a good one. The spines of the leaves, yes. So the spines are modified leaves. And if you look at the evolution of spines, this is like the end product. But if you follow the evolutionary history of the plant, you see that some cacti have leaves, and they have like green flat leaves, and they also have spines. And it's called an ontological series, which is a fancy way to say if you go and follow the plant over thousands of years, you can see how it slowly evolved into just this. The leaves became spines to endure the heat and to protect the cactus. Would the spine still be considered a petiole? That's a great question. I don't know. It could very well be petiole tissue with no blade. Sassy frog. That's a great question. If I had to guess, I would say yes. I would guess that it might just be petiole tissue. I don't know that. We'll look that up later. Or if you want to look it up now, let me know. That's a great question. So, everything follows the same pattern. Do cacti have spines that feel like fiberglass? Dirty goodness. I wonder if that's leaves too. Yeah, so there are 4 subfamilies of cacti. And the pad cacti of the Opuntioideae subfamily within the cactus family, they have big spines and they have the really tiny fiberglass ones called glaucids. The glaucids are pretty nasty. I don't think leaves make them... I mean, there probably might be some... They won't have the same structure. They won't be glaucids. But it's only the pad cactus are the only cactus that make the little fiberglass ones that are really annoying and stick to you. When you grow a new plant stem, they start as little buttons. Exciting. So bulbs. Bulbs are crazy. This little red disc is the stem. That is called the basal plate. So all the leaves are connected to the stem. And so everything else you see up here is leaf. All of these are leaves. And then when the leaves kind of dry out, they form this outer covering that's called the tunic. Each of these leaves is called like tunicate leaves. and then you have scale leaves underneath that. But if you cut this open, you'll kind of see that they're all leaves, and then you can see the green part up here. So the base of the leaf is sheathing them. Tunicate bulbs. So this presentation is for propagation, so I'll probably skip some of the propagation parts, unless you specifically want to see them. Caramelized onion leaves. Oh yeah, that sounds good. Most of your plant knowledge is practical, so very need to learn some of the more technical stuff. Exciting, yeah. I learned the technical stuff and then learned the practical. And so it was a fascinating reverse for me. But this is how you can propagate them. So there's other types of bulbs too. You might know garlic. It just is called, they have all these little scale leaves. So you remove each of these scales and you can plant that and it'll grow. Lilies look like this too. You can pull them apart and separate them and they'll grow. Corms. So if you know bananas, or crocus, or gladiolus, or taro, or calo, they have a corm. A corm is a stem, or sunchoke. Maybe it might be sunchokes too. I just don't know. They have flattened. Well, they have underground stems that are like compressed, and so everything they shoot up are just leaves. So banana tree, all the things you see are just leaves. This is the stem underneath. It looks like this, and then it grows up from there. Corms, they can make little baby corms called cormels. Isn't that cute? The cormels. These are gladiolus, the flower that looks like a sword. The sword flower, as you might say. There's also stem tubers. So a thickened underground storage stem. This is specifically stem tissue. And if you were to get a microscope and look at all the cells, you'd say, oh, this is actually just a stem. So you might know Dioscorea, the yam, or you might know the white potato. Those are stem tubers. It's stem tissue that we cut and eat, and it stores nutrients in it. You might know the rhizome. A rhizome is like turmeric, or lotus, or ginger, and bamboo, and ferns. It's the stem. Oh, sunchokes are stem tubers. Okay, there you go. The rhizome is a flattened, underground, horizontal storage stem with many little adventitious roots. Oh, so, Manny Boy, thanks for following. If you look at this, this is a ginger plant. And ginger creeps along with a flattened underground stem, and then the leaves come up. Lotus chips, yeah. I do like those. If you're going to cut or split them, this is what a banana corm would look like. You can also do that with rhizomes. But if you want to grow more banana plants, rip it up out of the ground. The stem is underground. And then cut it like this and plant those and they'll grow. You can do this with bulbs, cormels, and stem tubers. Stolons. So this is a specialized structure that connects the plants. It makes little baby plants at the end of stem tissue. So beach grass that's growing in sand dunes, makes stem tissue that runs out into the sand and sends it to roots down. And then strawberries do this too. Dirty goodness. You'll have to hop in later if I'm still streaming. I'm gonna go stream on the end. Sounds good. Nice hanging out with you, and we'll see you around, Dirty goodness. Sea bass, tulip bulbs. Yeah. You can split a tulip bulb. As long as it's not a scale bulb, as long as it doesn't look like garlic, then you can split it. I personally just split it twice, but you could even split it this many times. And bamboo is so banana is so resilient, it'll grow from just these. In a tropical environment, this thing's going to take over. Endless tulips. Yeah, you can get rich. Tuberous root. So if you know cassava or yucca, so you might know the yucca plant. The yucca plant has these tuberous roots that are storage tissue. This is root tissue, and the stem is over here. Sweet potatoes, dahlia, jicama, they all do these. They have the thick roots. Sometimes you'll get, yeah, I love jicama too. I always say jicama. I don't know if that's how you're supposed to say it. The roots sometimes will produce little shoots, and you can cut those. Cut the root off and then plant it. Root cuttings. You can take root cuttings. You can plant them vertically or horizontally. Bulbiles. How do you propagate jicama? Jicama, it's an underground root. So I'd have to look at it, but my immediate guess is that you could do a root cutting. You get a piece of it, or break a piece of this root, and then plant it, and it might grow. Kind of like potato, yeah. I would try that. There might be better methods, but that's what I'd do at first. Bulbiles. Bulbiles. This is one of our last ones, I think. Bulbiles are plantlets that arrive from the axillary bud, and they're often on inflorescences. So this is an agave bloom. The agave blooms once in its life, and then it makes flowers. And sometimes it'll, at the base of the flower, you know, there's these little axillary buds, because the flower is like a special modified type of leaf tissue. At the base of that special leaf stuff, it has the little bud, and it will make baby agave plants. And it looks like little pineapples on a big stick here, but those are agaves. When this stem falls down, because it will die, those plants, if they have proper contact with the ground, they can root and grow. So the plant blooms once and dies, but it makes tons and thousands of seeds, and it can make tons of clones of itself, called bulbiles. Bulbiles is a term often used for plants that form like a rosette shape, but it could be anything. You might know this one. This is the kalanchoe, or mother of millions, or mother of billions, or thousands. It makes bulbiles. So this is the stem up here, and then it has these flattened things that we might think are leaves, but that's also stem tissue. Sassy frog, yeah. The agave makes seeds and it makes clones. So it's making sexually diverse offspring, and then it's cloning itself. Coyote, hello. We have a special plant presentation on specialized structures of plants. The mother and daughter grow side by side. That's right, Sassy frog, yeah. So in the kalanchoe, it has stem, and it also has this flattened stem, and then it has these little tiny prongs. Those are the leaves, and at the base of the leaf, it makes the bulbiles, which are the baby plants. So this has a crazy morphology, and you might think that these are leaves. That's really stem. And then these are the little leaves. Okay, aerial tubers. So someone had said, oh, they thought potatoes grew on trees. That's fair, actually. There's some things that look like that, like breadfruit looks like a potato on a tree. But then aerial tubers. The Dioscorea bulbifera. Coyote, you have this one? Yeah, tropical plant. Are you somewhere in the tropical areas of the Caribbean, I think you might have said? It forms tubers on the vine, and these little things, you can plant them and grow them. And then I have pineapple here, because this is a fun final example of a specialized structure. This is an infructescence. Infructescence. Hey, there you go. You're in Jamaica, yeah. I remember. This is called an infructescence, which is a stem of fruits. And each of these little sections of the pineapple is one fruit. And they're all smashed together. And it's called a multiple fruit. And what happens is this plant is a bromeliad, a tropical plant from like South America and Central America, that bloom and makes a flower stalk. The flowers are pollinated by hummingbirds and other things. Mostly hummingbirds, I think. And then once they're fertilized, they become fruits. The fruits are, each of these things is a swollen ovary. One of these sections is an ovary, and they swell up and they fuse into each other. And then the plant keeps growing. On top of that, it continues to grow. And then so the top of the pineapple is just more of the continuation. The crown, as we call it. So I believe that's the end of our little special presentation. That was longer than I expected, but